ready to start. Cindy, can you start the recording?
We are being recorded.
Okay, welcome everybody. This is the third and last session of our workshop on barriers to internet access of services, BIAS. I'm moderating today. My name is Mia Kulewind, and this is the third sessions we had. We talked about community networks. We had the session on digital divide yesterday, and today the focus will be on censorship measurements, censorship circumvention, or anything else about censorship, I guess. Yeah, the workshop scope, I guess, hopefully everybody is already knows about this, but like this is the part where we actually talk about filtering and blocking technologies. And I think our goal is to kind of make an assessment where we are in the world. How bad is it? Is it getting better? Is it getting worse? And then also talk a little bit about technology implications, about circumvention technologies eventually as well, and what we can take away from how we design the internet and the internet protocols. This is also what you already know. We have a mailing list. You can use this mailing list also for discussion. It didn't happen so far, but maybe after the workshop there are more questions, so feel free to post anything to the mailing list. And we have the GitHub repo. I also want to remind people about this. There is an empty draft in there, but and we will start filling that draft hopefully soon after the sessions are over. But if anybody wants to help with putting content in, especially about your own presentation, you know, just write some text. It doesn't have to be much. It shouldn't be much, and put a PR in. So that's very welcome. Also, you know, already this workshop is recorded, and we publish the recordings after the end of the workshop on YouTube. But in case anything needs to be confidential, then please let us know. That's possible as well. We keep using WebEx for queue management, so please type +Q into WebEx if you want to take the queue. And also, as reminded yesterday, we want to have a lot of time for discussions. And you know, if we have open discussions, I encourage everybody to put the video on. It's always helpful to see people as well. And I also encourage everybody to engage in the discussion, because that's really the main purpose of the workshop here. The session today, we have actually 5 presentations, so we have to keep a little bit, have to keep an eye on the timing. So we still have some time for the open discussion at the end. But we get a lot of reports about deployed censorship techniques and how they changed over the recent years specifically. But then I also have invited 2 papers, 2 really nice papers here, about how to locate and evaluate or identify censorship devices. And the other one is then looking into maybe censorship circumventions. It's a study about VPN users and VPN providers, and looking at security and privacy aspects there as well. So I thought that is a good addition to the discussion today, hopefully. So let's see. So yes, that's my part. At this part, I already stopped sharing. And I hand over to Siti, who is starting with some IMAP measurements.
Yep, thank you, Mira.
Actually, I want to say one more thing. Sorry, I forgot about this. I also, just because it came up, so I don't think this is an issue, but as you all know, this is actually an invitation-only workshop. You all send contribution in some kind of way. That's why we invited you. And the reason for that is because we wanted to have like a good group size so people can engage in active discussion. So I hope that's seeing. Because the link to this WebEx was actually published in some ways. So we have seen cases where other people joined, but effectively this is supposed to be an invitation-only workshop. Just as a side note. And now you can go ahead. Sorry for interrupting you again.
Thank you. Let me share my slides. Is it okay? Are you all able to see it?
Yes, we can see it.
Okay. Hi everyone. I'm Siti. I'm from Sinar Project, an civic tech organization based in Malaysia. We do work on open data, transparency, and mainly to hold the government accountable. So we have I'm a technologist of this project called IMAP, Internet Monitoring Action Project. I will briefly first explain a bit about our project, and then we have published annual reports on internet censorship, the state of internet censorship of 10 countries in the Southeast Asia region, and as well as Hong Kong and India. So I will talk about mostly on the methods of blocking in these countries. Um, so IMAP is this project started since 2021 and actually it was supposed to be until this 2024, but it has been extended to another year to 2025. And our aim is to establish a regional and in-country networks that will monitor network interference in these 10 countries. We use data from UNI. I think there's Simon from UNI here who will explain more about it. Open Observatory Network Interference, open source data of internet censorship around the world. So our aim is to have digital activists who will in the regional and also in country of each of these countries and to monitor this network interference. So our project consists of these three main activities: contribution of data. So we increase the measurements on the Uni Probe, which is an app downloadable by anyone, and then anyone can just contribute to the data, whether via mobile or desktop. And then we will update the test list to improve the test list to make sure that it's relevant to the country context. And then we produce reports on annual state of internet censorship. We also built this movement where we try to have partnerships with as many as digital activists as possible in this region and also in country. And then lastly, we build capacity to network we build capacity. So our partners are not only those who are technically inclined, but more are also from legal background, and we try to have partnerships between those, and then to increase understanding on the net censorship testing as well as the results. So these are the more detailed activities of our project. Mostly our major project activity is the publication of the reports. We have published two rounds, 2022 and 2023 this last year. And then we have local partner workshops in every country. We translate only materials so that people can know how to use the app and increase measurements. We have also upcoming thematic reports on circumvention tools and also freedom of expressions. And we also aim to form a community of practice consisting of digital activists. So our methodology is using UNI, and we cover 10 countries. So this presentation will cover the latest report published, I think, around October last year. And the coverage is 1 year from July 2022 to June 2023. It covers 10 countries. And then we analyze data from UNI, where we see any measurements that are confirmed blocked and also likely blocked, which are possibly anomaly and failures. These are the ones that are not really confirmed that they are positively blocked, because there is no sign of censorship tracing leading to a block page or something like that. It could be anomaly, like the website is down or something like that. So based on the findings, general observations are in most of the countries, the categories of porn, gambling, provocative attire, dating apps, political criticism, and also news media websites are blocked. In this, I think 7 countries: India, Indonesia, Cambodia, Malaysia, Philippines, Thailand, and Vietnam. Whereas in another 2 countries, Hong Kong and Myanmar, we find that there are government websites, social media websites, and also military websites that are blocked, that are highly blocked in these countries. It's also quite anomaly that Hong Kong also doesn't block much on porn and gambling. But on the other hand, they block these categories instead. And then I will move on to the methods of blocking. In the report, there are more details on the legal background, on the country background, like the legal legislation or regulation used to block websites, and also citations to news that are blocking the websites. But this presentation will focus mostly on the methods of blocking, given the audience today. So I will explain in the form of like the general like I try to categorize the countries according to a few similar types of methods. So first one would be DNS tampering. So in these two countries, specifically Malaysia and Philippines, they have the government or the authorities that are in charge of censoring the websites. They have a specific IP address that they use to divert the website's IP address to their DNS. So specifically for Malaysia, it's 175 and so on, and for Philippines, it's that. And previously, there was a blog page for Malaysia, and now they don't have one anymore. So they are just censoring without any notice. Suddenly, we have website owners complaining on social media that their website is inaccessible, and when we test it with Uni or we try to see what DNS it's come up, it will be this IP address, and we will confirm that these websites have been censored. So lately, there are lots of cases of right-wing media websites that have been censored in Malaysia, whereas in Philippines, there are court orders on certain websites, military related websites of the right wing, and they are blocking of those group of websites, and there is a block page. But I think recently when I checked, there is no more block page on this IP address. So it could be that they have changed the IP or they have removed the block page. There is also unconfirmed censorship to 127001. This is also through DNS tampering, and also like empty domain, next domain. This happens in Hong Kong and Cambodia. In Cambodia recently, last year in February, there were blocking of news websites where VOD, one of the major independent news, was taken down. It was closed down, and that's why they started to censor VOD as well as a few other independent news websites. And the way they do it is by this DNS tampering. And next is geo-blocking. There is also geo-blocking of US military websites. This is actually from the US themselves. They prevent Hong Kong users to see military-related websites. And then in Myanmar, there are a lot of blocking of social media and communication websites or apps. So they, I think, among all of the countries, the major Myanmar experienced a lot of blocking of accessing of information. So major one would be Facebook, Twitter, Instagram. They are not able to access that, and they do this by DNS tampering as well. HTTP tampering is also observed in countries like Indonesia and India. So these two countries are they have a very structured way of censoring. So they have a specific court block list that they release, court or government block list. They are very transparent in some ways. Like Indonesia has a very organized block list where they put up the names of websites that they are censoring, usually pornography or gambling websites and so on. And then they would ask, there are many ISPs. So in these two countries, there are like hundreds of ISPs. So, and these ISPs will be blocking using DNS or HTTP tampering. And in HTTP tampering is also observed in other countries like Vietnam, Myanmar, and Thailand. So they have a blog page, and they are also they have blog pages. And in, for example, in Vietnam, there is a blog. When you go to a blog website, you can see this blog page, and they actually record your IP address, saying that this IP address has been trying to access this blog website. This is in Vietnam, but recently when I try again, it's not there anymore. There is also unconfirmed censorship through vague blog page. Like this is like they'll say that this page is unavailable, or there's page error or something like that. In Vietnam and Myanmar. And lastly, in Timor-Leste, which is the most we consider the most free country, there has been no censorship found, but there have been very poor connectivity issues in there, so that then they have a lot of failures recorded on our results. A lot of them, and especially this has proved trouble to accessing important information like on government websites, because they have a very poor connectivity over there. So the conclusion and recommendations of our report is to call for governments to be more transparent, so to use our data, to use our results on reports to be more transparent in implementing internet censorship. As we can see, a lot of countries in the ones under IMAP, when they block the websites, they don't notify anyone, or they just simply start to block it. And like, for example, in Malaysia, they just say that they block it because it's under investigation on whether it's a false content, it's a false news or not. So this has been very problematic in terms of human rights, and we want to call for governments to be more transparent in their process. And also to call for volunteers. If anyone wants to contribute to the project, we hope that you can contribute to the data, download the UniProbe app, and contribute to the GitHub and the test to update the test list. Yeah. Thank you. You can find our reports on imap.sinarproject.org, and my email address is as following. Thank you.
Thanks a lot. Very interesting. Already good start. We can take some clarifying questions. As I said again, I would leave most of the time for discussion, for open discussion at the end. But I actually said I have at least two questions. One is maybe a quick one, hopefully. Did you even try to also look into IP-based blocking? Do you know anything about that? So that certain IP addresses are blocked? You're muted.
Yeah, there are actually certain IP addresses are blocked, but they are mostly not really found in our country. I think there are a few IP addresses, but I didn't look further. Sorry. Yeah.
Okay. And then my second question is, you have this observation time of 1 year. Do you have any kind of, even if you didn't look at it systematically, do you have any kind of feeling if kind of blocking got worse, better, stayed about the same? What is the kind of the development over time?
It's actually, it varies into different countries. So censor websites have been, like from the perspective of users, it's gotten better because there are lots of ways to circumvent them now. But from the perspective of the government itself, a lot of them are increasingly, like in Malaysia, in a few other countries like in India and all that, they are increasing the censoring websites. Currently, a lot of them are into censoring scam websites, financial scam websites. So and the procedures are still very not transparent, and it's from the perspective of the procedure wise, it's getting worse because they are doing it without notice and without any, like, they are not having any block pages now. So that is what is worrying now.
Yeah, and actually my kind of third question, you touched on that already, is like, do you have any idea about how hard or easy it is to use VPNs or other circumvention techniques? Does it work in these countries, or do they also try to block these technologies?
They are also so as mentioned, we are also having another report coming up on circumvention tools. So an initial like when looking at circumvention tools category of websites, there are blocking of those websites. Like for example, in Indonesia, there are blocking of a few VPNs, and they are also trying. I think there are also mentions of like our partner saying that the port 53 is blocked, so people can't really change their DNS anymore. But so far, user-wise, it's still going okay. They are still able to access websites. But in Myanmar, VPN is illegal, so that is one thing that we are looking into. Yeah.
Okay, thank you. So Anu, again, if you have a short clarifying question, we take it now.
Yes, thank you. So the question I have is, I'm really slow and tired tonight. I don't know why. So I'm trying to get my head to ramp up at the idea. Do you have some clarity about how is this really implemented? I mean, is it that they have the law, that then they have some kind of group that makes the decision, and then it is, how is it? It's pushed to operators that have to implement that around the country, or how is it technically implemented when you say they block? I mean, what does it really mean?
Okay. So it's only obvious, very obvious in Indonesia and India so far because they have a block list. And they are quite transparent. They have presentations on YouTube about their ways of blocking. So, but usually it's based on complaints. In Malaysia as well, it's like by like word of mouth. There's, as they say, it's by complaints. So there will be complaints that say people report that this news article is it's false. It's telling a false something it's reporting something false, like a politician scandal or something like that. And then the police will make a complaint to this body, like the person receiving the report, they will look into that, and then they will make a decision. I don't know how they make the decision. Like for in the case of Malaysia and the other countries that are not transparent, and then they will they will add this to the block list. Like in India and Indonesia, they have a block list where they have the names of websites to be blocked, and then they will send it to the ISPs. The ISPs have to implement it. Yeah.
Okay, so this is operators have to either refer to that or import it or whatever synchronization mechanism, and then at operators level they are blocking that for the country. Okay.
So, but there are
also go ahead.
Okay, sorry. There are also cases where the ISPs do not follow. We have seen that. So in India is via the executive branch as well as judicial. There's a court order, and there's also the government, the executive branch that are blocking the websites. So like we have seen cases where ISPs don't follow the government orders, and it's also quite problematic because we don't. And especially when it's not transparent, we don't know like why is this ISP following orders and why is this ISP not following orders. So that is also another problematic angle that we are seeing.
So it's not homogeneous then.
Yes, unfortunately. Fortunately or unfortunately,
So, but I want to take this as a seg over also to the next presentation, because we will in the next presentation also learn more about also other countries in India, how this is done. There's sometimes also country government operated blocking in certain countries, and we have like more presentations about this going into detail. So let's it's a nice seg over. So let's take this opportunity and go to the next presentation. Thank you, Siti.
Hello, I'll just share my screen 1 second.
Yes, please.
Yes, so thank you so much, and it's a pleasure to be here also with people whose work this presentation builds on. I think hopefully I'll also try to like skip over some parts that Siti already covered in their presentation so that it's not repetitive. But Actually, a good place to start is the
We
questions
lost your
that were.
sharing. I think you have to
I'll
reshare
just do
again.
that.
Okay.
Okay. So, yeah, in India specifically, like perhaps this will continue the discussion where we left it off. Uh, the government has the power to basically issue orders to internet service providers, which are mandated by their license agreements and by different laws to comply with these orders. The central government at the union level and different courts in the country can pass such orders. And uh, just as background to this like research project, this the paper that I'll cover now was with Divyan Katira, Kushagra Singh, and Varun Bansal. And the ethical background is like Indian law doesn't specifically prohibit accessing blocked websites, and so we like when we ran these tests, like we also have like a detailed legal and ethical analysis for these measurements. And uh, these like to an average user might appear as like random events because there is very little just to like add a bit of caveat to what Siti said. There these orders, when they're published by the government or when they're sent to ISPs by the government, then they're not published in the public domain. And so we just find out like if we're trying to access it. And in fact, we have the Right to Information Act that allows us to request information from the government, similar to the Freedom of Information Act, I think it's called in the US, where but we've had so many instances where we file an RTI request and actually say that they had no clue that this is blocked, but we suspect that it was because of government issued orders. And the research questions we were trying to answer were, what methods are ISP using to block websites, which I'll cover very quickly because the last presentation already covered them. And second, a look at when related to the question Arnaud asked about like, is this blocking homogeneous at all? And there are certain reasons why we couldn't use Uni and Censored Planet and other tools for this work, mostly because we had like a massive list that we were trying to study, and there would be like performance and other limitations in those tools. And Censored Planet is aimed at detecting it bi-directional censorship, so it sends packets from the outside to test it. So it wasn't usable for our case because in India lots of ISPs have unidirectional ISPs, so they only censor based on what's going and not coming to the user. So what we did is we created a list of potentially blocked websites from mostly court orders and user reports, and some government orders have been leaked or have been made publicly available, and then we considered those as well. The ratio is that these were mostly court orders, and this will be like relevant to like how we in a second actually. So we filter that list. We're like only looking at domain level blocking and not specific pages, and we like end up with a list of like around 4,000 websites, and we test this from 6 major ISPs in India. And the market is very concentrated, at least at like at the national level. So like these ISPs basically serve 98 to 99% of internet users in India. Now I'm gonna skip over these parts, but basically the methods that we test for are DNS tampering and poisoning. So poisoning is when the ISP's DNS server contains like a manufactured record for a domain name they want to censor. But there's also injection where they're just monitoring all DNS requests and censoring those. And our methodology was to look. So why the court example? Why the fact that our list mostly contained court orders was relevant is because we have a high confidence that these are actually censored, right? Because the court has ordered them, and we know that they're in the public domain. So we look at the concentration of a response that appears with the frequency that other DNS responses don't, and this turned out to be a really good heuristic to find out like what um, IP address that this DNS record was pointing to, and that's how we discovered which websites were blocked using the DNS method. And then we also tested for HTTP-based censorship, and where the ISP looks at the host header, or I mean, it's all in plain text, so the request or the host header, and they block the connection based on that, and they send a censorship notice or don't, really, some of them. Our heuristic here was to like filter like what are known sort of responses of like HTTP blocking, like different response codes, but also we compared it to like a legitimate response, and like our I'll skip the details of this heuristic because I'll try to focus on some other questions later in the presentation. And finally, HTTPS-based blocking. Now, the fact that the server name indication travels in plain text can be monitored. That part of the TLS HTTPS request can be monitored by ISPs, and then usually they just when they want to censor a request, they send a reset or they just like drop the connection so it times out. And for this, we had actually set up our own server which accepts any SNI, and therefore we were able to see which requests were blocked on ISPs. And this slide is slightly outdated, but basically at the time we did this, you'll see that some ISPs are actually using multiple methods so as to, like, let's say someone is evading DNS censorship, they'll get like blocked at the HTTP stage. And this is in 2019. So back then only one ISP was using server name indication based censorship, but now Airtel and Vodafone on this list are also using it. And an interesting fact is that they're also like not even uniform within an ISP. So they're used like ACT, for instance, from our list was censoring 233 websites by just using DNS, and HTTP like some 1800, but both in 1615. So that's only DNS was used for 233, only HTTP for 1800, and both on 1600. And this is just an example of that across ISPs. And in terms of transparency of censorship, with DNS and HTTP based censorship, there's the possibility of sending a censorship notice. Either you redirect using DNS to an IP that you're hosting and that has a block page, and but we found that, for instance, Airtel was not even doing that. It just responds with NX domain, so you actually an average user doesn't end up seeing anything. And even in HTTP, sometimes they're just, again, Airtel was the culprit here, which was only sending reset packets. So you just end up seeing an error on your browser, for example. There's some level of collateral censorship, which we can discuss later, but how we describe that is, let's say you're at a smaller ISP X that has like some transit relationship with a bigger ISP Y, and these packets actually end up passing through X normally because X is not censoring the website, but then counter censorship at Y. So there are we have instances of that in India as well. In terms of transparency, when SNI based censorship is used, censorship notices are actually not even possible because you can only send a reset packet and not like inject a response. What we found also is that the blocking is not homogeneous at all. Out of this list, like this is just the number for each ISP. As you can see, Airtel, while it was not being very transparent with its censorship, it was blocking the least number of websites. I'll come to the reasons why this happens as well. And so as an example of like this, only around 27% websites were blocked by all 6 ISPs in our list. The rest were at least not blocked by a single one. And yeah, this was just a comparison of block lists across ISPs just to see like how much they overlap. And I think the biggest overlap was like between Geo and MTNL 85%, but the others are in the range of 40 to 50%. So what this indicates is that ISPs are either not complying with these orders, or if an unblocking order is issued, then they're not complying with that, or they're arbitrarily blocking websites without a legal order. And a sort of a good finding from this is that India has net neutrality regulations, and they prohibit blocking websites without legal cause. And so in this research also uncovered some evidence that ISPs are also like sort of operating unlawfully in some cases. I'll also just now quickly cover like some follow-up to this research, and now I'll also start to focus on a little bit on how the sort of the levels at which this censorship occurs. So after we did that project, we sort of expanded the project to have like an app that allows sort of testing across the country, much like Uni does. At that time, we were not able to use Uni because of like performance issues, and we were testing for like 10,000 websites. But a similar methodology in terms of data collection and like the tests. And now we had data from like 25 states, like 31 ISPs, like approximately 9 million measurements. And so this is like, even though they serve less users, this gives us a more comprehensive picture that SNI blocking was like a little more prevalent than we thought from just the 6 ISPs, and HTTP based and is the most popular method, while DNS is not that quite popular now as a blocking method. And again, we uncovered like huge variations between block lists. And perhaps this is a good time to mention why this happens. When the government sends orders, what we understand is that they're like literally sending PDFs. So the ISP can just like decide how to block them, how to process like whether to block the domain itself, or if let's say the PDF says you should block www.ietf.org, then they might just end up blocking ietf.org, or they like paste www.ietf.org. So like that's one example of how like variance can happen, and like at what level these websites get blocked. Sometimes they receive a URL and end up blocking the entire domain name. And this paper, we also try to contextualize this measurement data with specific legal orders. And again, we found multiple instances of non-compliance with order, of non-compliance with unblocking orders primarily. So the court says, oh, we blocked this in 2020. In 2021, the other party won the case and the sites were ordered to be unblocked, but the ISPs just never ended up implementing like the unblocking essentially. So they kept it on their list. And now I just quickly cover some more research. When this research was hosted at Uni when I was working as a fellow, and now using Uni data also analyze like what infrastructure is actually doing this censorship, and also the laws that sort of empower it. And just to recap, in India, the government is sending orders to like private and public internet service providers, and these ISPs are responsible for implementing this censorship. They're not even told what method to use. So as we saw, they just end up doing whatever they want. But we found no evidence of censorship at the internet exchange level, at least. And India has like sort of diverse interconnectivity where ISPs are free to choose even what international networks they connect with. So there's no centralized sort of infrastructure for blocking. Now, as I said earlier, the list of websites blocked is, we have to sort of compile them through RTIs and requests, and even then we only get what the court ordered to be blocked and not the government. Now, let's go to the westerly neighbor of Pakistan, where the official list is not available, and censorship is occurring at different levels actually. So there are both private and public ISPs, and the government similarly issues orders to ISPs, but they also have state-run internet exchange points where the censorship is implemented. And I won't cover the methods for Pakistan, but they at this level they are doing like HTTPS monitoring. And in the recent years, there's only been even a more trend of like centralization. And this term I'm borrowing primarily from Professor Roy Safi's work, where Censored Planet's work, where centralized is like if the state is controlling infrastructure, or like there are choke points that at which this happens, versus decentralized where ISPs are primarily responsible. So Pakistan has deployed what they call the web monitoring system, and this is essentially located at lines of international connectivity. And why they're able to do this is because, in contrast to India, most ISPs and ASs in Pakistan actually like end up leading to two ASs mostly. So one is the Pakistan Telecommunications Company, which is a state-controlled ISP, and the other is Transworld, which is a private company. But so most traffic of Pakistan actually goes through these ISPs, and they have like international connectivity. So at these ASs, they have internet exchange points, but also like what they call all exchanges in their tender as well. There they have deployed infrastructure that monitors this traffic as well. And now just the third country, and I'll, conscious of the time, I'll go very quickly. In Indonesia, you have a little similar to India, as Siti also covered, which is it's also decentralized in the sense that ISPs are primarily responsible for blocking, and like India, they have diverse interconnection and international connectivity. And the government sends these orders to ISPs. The slight difference is that this list is partly maintained by the government, what they call the Trust Plus Positive list, which is available publicly, but their regulations also offered some technical guidance on how to sort of implement this censorship. And another huge difference is that in 2020, some regulations in Indonesia allowed ISPs to block websites at their own discretion. So in India, while the legal status is like you only block what we tell you, and the other you shouldn't block because of net neutrality regulations, in Indonesia, the law explicitly allowed them to censor websites at their own discretion. So services like Vimeo and Reddit in the past have been blocked only by not all ISPs, but like some of them at their own discretion if they felt like it was hosting unlawful content. There's a slight centralization trend but this hasn't actually happened, but there have been proposals about centralizing DNS queries. And I didn't mention it in the case of Pakistan. The Pakistan government also proposed this, but the ISPs sort of pushed back and shot it down. In Indonesia, the ISP providers association and like the network operators group has proposed this, but when I did the analysis, I couldn't find any evidence that there was censorship at that level. So just like 2-3 sort of discussion points for later perhaps are that the title of the slide quotes like Kendrick Lamar, that we should be humble, and there are like censorship at the ISP level, at the internet exchange point level, and lines of international connectivity. So we saw censorship at all three sort of places in the case of Pakistan, while in India and Indonesia, it's mostly at the ISP level. And there's a distribution of like public or private infrastructure at all of these things. And the second thing is that when it comes to these private ISPs, many are actually more executive minded than the executive, and they're blocking websites that they're not supposed to. In Indonesia, they're legally empowered to do that, and they are actually doing that. And in terms of like where advocacy can go with this is that these ISPs also need to be targeted about their practices, and we also developed a sort of framework to assess them or like ask them questions if that is of interest to people who are engaging in that work. And these network measurements can also uncover unlawful practices, as we saw in the case of India, where many ISPs are violating net neutrality regulations by blocking what they're not legally supposed to. In terms of centralized versus decentralized infrastructure, and it's just I hope like the work can sort of demystify the fact that there is no Great Firewall, even in the case of China and Iran, and most censorship is happening at ISP levels and sometimes at centralized infrastructure, but mostly in conjunction with the ISP level censorship. And decentralized control doesn't necessarily mean better outcomes in terms of civil liberties or freedom of access to information or freedom of expression, because as we saw in Indonesia, it's decentralized, but they're censoring more than they're supposed to at their own discretion. And at least theoretically, even though like some case studies, like there was no appropriate case study to say this, but if you have centralized infrastructure, it may not necessarily mean that it's worse for those outcomes. It could just mean like other things, like the state is investing a lot more in providing access, etc. Now I'll just quickly cover like in the India work, there is also IP level censorship that we didn't cover, and so IETF has made great progress in the last few years of like private DNS methods. Quick also was a significant advance because SNI traveled in plain text in earlier, but if you're using Quick, then it's at least obfuscated to a level where the censor has to do more work to decrypt the first exchange, which increases the cost of censorship dramatically. And now if we have widespread encrypted hello deployment, that some of these methods just become unviable. I don't think it is easy to, or that there's like significant progress in preventing IP level blocking, which is something that remains a design question and a deployment question for the future. But as we also like in terms of future research, and this is the part where I speculate, but when HTTPS was getting popular, what governments ended up doing, and especially in India, they started sending notices to these servers and services themselves, right? Like, so now you can't censor a specific video on Facebook because you can't really look at a URL in HTTPS, so you send a request to Facebook. So I think what will happen now is like more sort of protocol level blocking, or you actually tell like the encrypted open DNS resolvers to censor or like geo-block requests. This is something I hope to explore soon in a project as well. And in Iran and China, we've already seen blocking of like privacy preserving protocols entirely. And this is a question that ITF is also aware of, like how can we ensure coordinate on deployment like informally, so that it's infeasible or impractical for a government to order the blocking of a new protocol, let's say. I'll stop sharing, and I'm so sorry for taking more time than given.
No worries, it was really interesting. And I actually have two questions which relate directly to what you had on your last slide. One very practical question. So I saw that there was at least one ISP in India who was only relying on DNS-based blocking. Did they also take any kind of efforts to block other resolvers to like ensure that traffic goes to their resolvers?
No, so the only IP level blocking. So how could like one blocker DNS resolver would be either to drop all DNS traffic or like IP filter it, but we didn't find any such case in India. There are some cases of IP level blocking in India, which we uncovered after this research, but they were mostly like a random code saying like actually blocked a Cloudflare IP completely because they just didn't, they just like went with the petitioner's demand. And not, so it's not happening in a concerted way is what I mean. And we also didn't find evidence of an entire protocol being blocked in India.
And related to that, can you explain a little bit more what the legal obligation, maybe in case of India, actually is? Because if the government just said you have to block this website but doesn't give any technical guidance, like how much do they have to do to actually ensure that it's blocked, right? Do they have to break encryption? Do they have to like make sure the DNS server is used or whatever? Apparently they have not, but what is the legal obligation actually? How much do they have to invest in that?
Yeah, so the legal obligation, the laws do not specify what methods they have to use. I presume that there's some informal pressure to be like deploy techniques that are more effective at blocking. And I tried to interview ISPs in India and Pakistan to understand what they were like, whether there's any informal pressure or like what is the formal pressure. But I was not successful at like getting a single one on the record. On just what the formal pressure is, actually the license agreements in India at least state that and Section 69A of the Information Technology Act has fines and also like a jail term for like non-compliance. So it's not that I've seen any ISP like go to jail for this, but like or like the executive of an ISP go to jail for this, but at least legally that exists.
Okay, thank you. We have a bunch of questions. So Suraj.
Thank you. Thanks, Krishnavad. Like there's really good presentation. I had a question about the commonality of the thing. So like you said, like about 27% of sites are like filtered by all the ISPs. Would it be fair to assume that that's kind of the government notices and the rest of them are like really the ISPs doing it, or like am I stretching that too much?
So that figure was based on sort of one single vantage point, and so the figure was slightly larger when we reproduced it across the country and on multiple ISPs. But I really think like the explanation I was giving when like even if I was an ISP, I received a PDF with like sometimes 700 like URLs, right? And what we did is like we also had the same PDFs, right? And like some of them at least. What we did is just preserve the domain name and then look for just do DNS, HTTP, and HTTPS request to that domain name and see whether it's blocked or not. They may be implementing it in a different way that like only preserving specific subdomains when they're given a URL, like blocking the entire website. And that's why I think the number seems low. I think practically it would seem slightly higher. I think this is I think the methodology creates that like slightly exaggerates that in my opinion, but it also illustrates like what would happen if we were an ISP, right? Like we're also interpreting the orders, I guess, in the same vague way.
Perfect. Thank you. Thanks.
Next we have Mallory, I guess.
No, sorry, I took myself out of the queue. I think Arnaud is next.
I see. Plus Q minus Q. Okay, I'm getting the algebra here. Right, so thank you for this presentation. Frankly speaking, I am really amazed to see how is it that these countries want to make this censorship effort, and it is such a pathetic implementation, just the irony of it. But it's a comment on the idea that indeed governments, from what had been my experience like 20 years ago, in fact, they cannot dictate the way you do it technically. They cannot. They will just say, On our side, we say this is the requirement. How you implement it, we are not supposed even to know. That's your call. What's more surprising is that they do not have a way to understand the efficiency about what they are doing. Because probably speaking, the efficiency is like, I'm trying the ironic point of view of their side. The efficiency that they are doing is like poor. It's not coherent. It's not correct. It's as you pointed out, it's zerotism to implement it. It is really
yeah, I know, and this is a really an important point, but let's keep that for the discussion at the end. Let's go to the other presentations, which give us some more data. So that would be great.
If I may just
Sure.
a 15-second response is,
Yeah.
I think if we step away from the technical and look at the practical experience of users in India, the market is so concentrated that only 2 ISPs need to do it properly, right? And if they do it properly, you are affecting like 95% of the population. And this is what I'd say is the reality, because Jio and Airtel are the most popular ISPs in India. So practically you've achieved what you wanted to. Second, I think some governments are aware that they should, not that they should, but they can look at the technical details. And South Korea, for instance, I think 2022, they issued guidance to ISPs that all of you start blocking based on SNI, right? Like if you already aren't. So these countries will also like start something similar.
Guys, thank you. That's really great. Thank you.
Thanks a lot. Yes, I just realized. So we have a bunch of presentations to go. So let's go on to the next one.
Okay, I'll share my screen, which should be a second. And you should now see it, I suppose.
We do. Now it's full screen.
Okay, perfect. Do you see the laser pointer?
Yes.
Okay, awesome. Okay, let's, okay, maybe I can also remove this part. How do I do this? Okay, let's go. I'm Simone, I work at UNI, and I'm telling you about this research report that we wrote that describes how we, like what we measured about changes in the censorship landscape in Russia during the first year of the conflict in Ukraine. I'll tell you about UNI very briefly. Others had already touched upon it, but yeah. So UNI means Open Observatory of Network Interference. We are not profit. We write this UniProbe app, which is open source, and the gist of it is that people can install it on mobile, on desktop, and on CLI, and it can measure a variety of things. By default, data is sent to our backend. The backend processes it in real time. We have a website called UNI Explorer from which you can see the data. And then we engage into writing research reports in collaboration with partners. And what I'm telling you about today is indeed a research report. So let's first take a little detour about the app. Okay, these are 4 screenshots from the app. And what I want you to visually see from those screenshots is that we have several things we can measure, right? So we have websites here, instant messaging, etc. Okay. For the purposes of today, we just focus on websites. And all our measurements can run automatically in the background or can be user initiated. But in any case, when you're measuring websites censorship, this is what happens. So the application, UniProbe, contacts our backend and gets a list of URLs to test. And this list is drawn from a larger pool that we call the test lists that we maintain together with the citizen lab. Those URLs are divided by categories, which will be interesting in a second. In any case, the app receives the URLs, and then it's basically going through each of them and trying to measure it, as you can see here. And so measuring a URL basically means, conceptually it means, you do a little bit of DNS queries, then you have IP addresses, you try TCP connecting, then you TLS and check assuming everything is okay, and then eventually you got a single connection from which to fetch a web page. Now, in parallel with this process, we are also running control measurements, which use test helpers, as we call them, that run from like uncensored locations. And then at the end of a measurement, we have both what the probe has observed and what the test helper has observed. And then by comparing the two, we can say whether to put like this green tick here, which means they both saw the same thing, or whether we can put the cross in there, red cross, which means basically, look, maybe like typically what happens is that the backend was able to obtain a web page where the probe failed somewhere in the middle. So yeah, that's the thing we are talking about. Now, I want to start getting into the report proper. What I'm going to do is basically skim through the structure of the report and commenting on it and telling you about stuff that is relevant while not going too much into some details. Okay, so the first thing to know is that obviously when there is a conflict, the level of information controls increases, and this is useful to control the narrative. So at the beginning of the war, in March 2022, we wrote the first report about this. And the report discovered that the news media websites have been blocked since the beginning of the war. And then this specific website also was blocked. Then we discovered that Twitter was being throttled. And then eventually it was blocked. And then also Facebook was blocked. But 11 months ago, we asked ourselves again the same question, but the aim was, okay, what changed since then? And to do this, we partnered with Roskomsvoboda, which is an association fighting for internet freedom in Russia. So the report is basically, okay, 1 year has passed, what has changed? Let's look at the TLDR. So the TLDR, it's 494 domains that now are blocked. Some of them are not part of the official blocking registry, about which I'm going to tell you in a bit. And then, yeah, we're blocked where human rights websites, be them international, Russian, journalism and news media, and then Instagram, SoundCloud, and Patreon also were blocked. And then there was other funny stuff like Tor was not blocked for a little amount of time, then it was blocked again. But let's move on and let's try to move fast. Okay, I told you there is this official block list in Russia. The entity that maintains this block list is called Roskomnadzor, which is like the authority that controls communication in Russia. The content of this list is either IP addresses, as you can see, or domain names or URLs. The first step actually in our report was, before looking into any data, let's look at how this list has changed over time. So for historical context, this list was established in 2012, and then over time, there were various redefinitions of how it is possible to add stuff to this list, on which I will touch upon in a second. Okay, the first chart I want to show you illustrates what happened in 2022 in terms of monthly additions to this list. And you basically can see quite easily that there was like a bump in the number of entries that were blocked, which more or less is coincident with the beginning of the war, then like a little slowdown, then December was really a bad month for censorship. I don't know why, but the thing is that obviously some administrative government activity went on to block new stuff. And the actual report goes more into details about the whole legal context and background, which I'm not going to do here. But if you read the report, like those stuff are a bit more contextualized. In the interest of being quick, okay, let's move on. Now, I told you that there are several ways of inserting into this list. There are court-specific ways, but there are also either branches of the government or authorities that have the right to put new entries into this block list. So you see here the Federal Tax Service and Roskomnadzor itself can do that. And the law was amended over time to like define who can do and add to this list. So for example, this is quite interesting. We have 3,500 entries that we don't know who added them, but the thing is that they seem to be resources related to something like criticizing the armed forces or defaming the armed forces. Okay, well, that's what happened in the official block list. Now let's see what we did see thanks to our users who were running Uniprobe. Okay, the first view I would like to show you is like a high-level view. And this high-level view is based on fingerprinting. So it is what CT called confirmed blocking. That means that when we receive a measurement from a Uniprobe, we have a bunch of fingerprints that usually are IP addresses or web pages content that we know that they are associated with censorship, like pages saying, look, you cannot access this resource because of this law, stuff like that. So we are limiting ourselves here to stuff that we automatically confirm based on fingerprints. And then there is this chart, and I told you that the task lists are divided, and that was also obvious from CT presentation, are divided in categories. So you see here, we had lots of news media that was blocked, but we had other categories, I don't know, gambling, social networking, whatever. Like we had many. And indeed, we have 30 categories, 28 of them, they were blocked. They had at least one blocked domain in the period that we were monitoring. Now, the relative size of these bubbles is not really important because, first of all, we don't have the same amount of URL per categories. And second of all, the way in which we schedule tries to as some algorithms behind it, by which we are not scheduling categories evenly. The main message here is just across the board, several categories of websites that range from political criticism to pornography to gambling, they were blocked. Okay, so at this point, the report is basically going to say, let's take a look at some changes that we observed. And I summarized them here. You see high-profile human rights organizations, investigative journalism. There is a potential block of YouTube. It's a bit unclear. There is definitely SoundCloud and patterns, etc. And I don't want here to go in depth into them. I just want to show you one case. So this Ukrainian website. And this is what you see if you look into the data. So we have this time going on here, and we have an histogram for each day. And then you see basically there is some color coding that tells you the amount, like the height is the number of measurements per day, and color coding tells you the state. And okay, obviously, means the control measurement was okay, and the Uniprobe also could access the resource and everything matches. And what we call anomaly instead is when the control measurement was okay, and the probe failed somehow. And yeah, we did this for most of the websites listed here. I'm just showing it to you one case. And to conclude, I'm a little slice of a larger chart where we classified how the probe failed. So same website, and here we have rows. Each row is an autonomous system number. And then again, we are using this convention that we are partitioning using color codes to communicate what happened in terms of the outcome. And okay, obviously green, okay, you see there was some green, and that probably also was because we started measuring a little bit before. In any case, there is a bunch of TLS problems that can occur. So they mostly go like this. You send the SNI as part of the client allow, and then connection reset is like, okay, you just receive a reset. Generic timeout is more like you never receive any packet back. The handshake does not make progress, so eventually you give up after, I don't know, 10 seconds or something. Some cases where the certificate was wrong, those are interesting, but not as many as okay, so this one, EOF error, was a bit more common, and it's similar to reset, just gentler rather than reset just FINAC, and then you're done. And then a little bit of DNS, but mostly what we observed was TLS interference. And yeah, that was it. And I'm done, and I'm ready to take questions.
Thanks a lot. Also, I think very interesting and nice to see, as an addition to the previous two talks. I don't know, I don't see anybody in the queue yet. But I wouldn't mind if we don't have too many questions and just move on, because we're already late here. So thank you. Let's go over the next presentation. I think Mona, you are on, right? Yes, perfect.
Yes, I am. Thank you so much. I'll try to blitz through this because I know we're behind. let's see. One second. Is this the correct screen?
Yes, it's not full window, but it would be okay, I guess. Yeah.
Wait, 1 second. Let me see if I can. Sorry about that.
No worries.
Let me see if I can full screen like this. Sorry. Is this better?
Yes, it is.
Okay.
Perfect. Go ahead.
So I'm Mona. I'm a PhD candidate at Princeton University with the Center for IT Policy. And this was a collaboration we did with Censored Planet, which has been mentioned already in one of the previous talks. And our work was primarily producing network measurement methods for locating and examining censorship devices, which we've also heard about. And just as a very quick background, in the past decade, we witnessed many censorship and surveillance events and an increase in network controls across the world. There are a lot of well-established censorship regimes. Many of them have been discussed already, those in Russia, China, Iran, and even India. But this eagerness to control the internet and control access to information is spreading very quickly throughout the world. So, and as additional background, much of this spread has been made possible by sophisticated like DPI technology that is also available now on commodity network devices, the sort of devices that a bank or a large enterprise might buy. These devices are able to inspect and tamper with large amounts of network traffic, and these advances and the commoditization of deep packet inspection technologies have made the censorship capability increasingly available for smaller governments and even smaller ISPs who want to comply with government orders. So the proliferation of censorship enabled by these devices today is a global problem. These techniques and targets, our targets, are evolving across time, which introduces huge challenges for us as researchers. 10 years ago, maybe we could just focus on targets like the Great Firewall, taking a look at like Iran's national censorship system. But nowadays, it's no longer sufficient with the sort of very rapid spread of network controls across the world. So also research from the Internet Freedom Community has shown that studying these network devices can also lead to positive changes for internet freedom. Research from actually another set of collaborators, Citizen Lab, have found that devices manufactured by a Canadian vendor that first sold enterprise network blocks were being used to block LGBTQ websites in many countries at a nationwide scale, something that NetSweeper actually advertised as a feature. And after this advocacy, they removed the option to block LGBTQ websites. These studies have been useful targeting specific vendors and targeting specific cases, but there have been very few. And what we want to do is sort of operationalize this sort of study. A lot of studies, understandably, focus on what contents are blocked, when are they blocked, and from which locations. This work is super important, and active censorship measurement platforms like Uni, which we talked about, and even Censored Planet, could you tell you, for instance, whether you access to YouTube or another website is blocked for a particular client somewhere. So this specific work we're looking at is also interested in doing the question of who is doing the blocking, where is the blocking happening, and how it is happening. Previous work, like I mentioned, is exclusively focused on specific censorship systems whose behavior is better studied and more well-known, such as Great Firewall, Russia's TSPU system, Iran's national firewall. And so this focus on specific well-known censorship systems is because studying censorship is very difficult. There's very little transparency from vendors or devices performing these censorships and from authorities that are deploying and mandating this behavior. To add to the problem, now there are so many different censorship techniques and inconsistencies between how different devices behave. In addition, a lot of the research that has been done in the past involves a lot of manual forensic work, which is very hard to scale. So what we were trying to start is to build general purpose robust methods to study censorship devices at scale and to characterize the methods of censorship. And so I won't get too much into this, but generally we try to build tools, for instance, a censorship-based traceroute. We built a censorship fuzzer to look at censorship triggers, and we also combine these techniques, including other fingerprints of censorship, to see if we could cluster devices across different countries. So I'll talk very briefly about the censorship traceroute. So for this project, we looked primarily within former Soviet countries because we were interested in the proliferation of censorship techniques from Russia to the surrounding area. And so we conducted HTTP and TLS-based trace routes containing often censored payloads in 4 different countries. And so the first type we conducted from Sensor Planet's vantage point from servers outside. And then we also conducted in-country measurements as well. Just to give you a sort of map of what this was able to find, using our censorship traceroute, we are now able to identify exactly at which hop and between which ASs censorship is happening. So to give an example for our remote trace routes to Azerbaijan, the root node at the left is our measurement machine in the US, and then the leaf nodes are all the machines in Azerbaijan that we perform the trace routes to. And we noticed that the censorship almost always happens on the first hop into the country, likely at the internet exchange point. And so this characterizes a little bit how the censorship occurs in Azerbaijan. In Belarus, we noticed that the censorship, unlike Azerbaijan, happens a lot closer to the user, typically in residential or smaller ISPs. In addition, we saw a lot of on-path RST packet injection in Belarus. And here is our figure for our remote trace routes in Kazakhstan. There are a few interesting things here. The first is that a lot of the censorship occurs about 2 or 3 hops before the endpoint, typically in ISPs a little bit upstream from the client. There are also some very interesting cases that we'll zoom into. Yeah, so these 2 cases are interesting to us. And so in this case, we actually see that the censorship is happening in Russia, even though the probe is has a destination to a client in Kazakhstan. We have observed a number of cases like this where the censorship policies of one country affected traffic going to and from others, which has super significant implications for censorship measurement. Because usually they're mostly reported from the geolocation of the host or the endpoint of the censorship. Anyway, so these are some of the interesting observations we made with our centrist methodologies. Significant portions of remote measurements are blocked at the endpoint, indicating very local policies for censorship. There are very different methods that were used. So when we perform these trace routes, we observe different methods of censorship being used. RSTs were injected in response to our trace routes. We had packet drops, and we had to characterize all of these different sort of censorship methods as well. So the next step in our work is we wanted to see if we could identify device vendors. Some previous work from Censored Planet was looking at HTTP banner grabs and HTTP, other HTTP injections, and characterize the vendor from collecting this data and clustering it. And so really quickly, I didn't get too much into the methodology, but we did find, a lot of the network devices being used in these countries were manufactured by commercial vendors such as Cisco, Fortinet, and others. These companies usually manufacture security firewalls to be deployed by corporate organizations. So our study shows that like sometimes these commercial devices sort of serve a dual use purpose for network censorship in some cases. And so the same technology that blocks network attacks for corporate firewalls can also be configured sometimes very easily to block legitimate network access. And the next question we wanted to ask is, can these sets of censorship devices actually be distinguished by their behavior? As we mentioned, a lot of these censorship devices are increasingly less transparent about the fact that they're censorship or sort of attribution, or where the device is coming from or being manufactured. So we were interested in addition to this in seeing if we could cluster network layer fingerprints or censorship behavior to see if we could identify them just from the network footprints. So we also developed this censorship fuzzer, which tries to reverse engineer censorship triggers at the application layer. So here, in TLS, we can see by changing the cipher suite and TLS version, we can evade many sensors in Russia, and adding padding to SNI evades a lot more sensors than you might expect. This is a fingerprint then that maybe we could use to identify, in particular, certain devices that are used in Russia that are not used in other places. We have a lot, a huge wealth of results from this fuzzing that I won't get into, but the full list I can be found on the website or our paper, which I'll share the link to at the end. Anyways, so at this point, we've identified many pieces of information about these devices. And so the next thing we did was to put all of these features together to study similarities and differences between these devices. So we took features from Suntrace, Sunfuzz, banner grabs, Nmap probes, and clustered this data using standard clustering techniques. We labeled the clusters using the vendor information that we obtained from our batters whenever that information was available. Here was a preliminary look at some of our early results. So these were generally the clusters that were formed. You can kind of see each individual cluster has an ID and has like a column. And we've labeled these a little bit. This one was Cisco, this one was Fortinet. Oh, sorry. And you can also see, clusters with devices from different countries have the same features, indicating a lot of these commercial filters are being deployed across different countries. Some of these other clusters we weren't able to find attribution for, but I think it's promising that many of the censorship devices being deployed by the same countries are also being clustered in similar places. Anyways, so I'll just cut that off here. We have all of our code and data are fully open source. So if you have interest in these techniques, or if you have interest in some of the data, feel free to take a look. Feel free to reach out to us. We're hoping to advance mainstream censorship research with more in-depth understanding of the censorship and the technologies that enable it. I'll stop there.
Yes, thank you. I think this is really important work. This is kind of my hope that learning more about how these things are deployed and work in depth is actually something that will help the Telnet community to develop better protocols and make the internet more secure. So I think this is like really good work. Thanks a lot. I have one quick question. So did you, because these are, of course, not censorship devices that I use, these are, as you said, commercial or corporate firewalls usually. Did you reach out to vendors of these devices and kind of try to talk to them about like this dual use?
We have not, but we know that other folks have in the past with mild to varying success. In general, it's very hard also, in addition to show to prove the attribution of these devices are being used for censorship purposes. In many cases, It seemed like the networks were going to, for instance, schools and universities, in which case, like, I think it's bad that schools and universities are censoring their networks, but it's also like they're clients of these like large companies. If folks have thoughts on better ways we could do this sort of advocacy, I'm also happy to hear it.
Yeah, I mean, I think it's challenging to avoid this kind of dual use, but that's actually what I hope to start a discussion there with respective people as an outcome of this workshop. So I don't see anybody in the queue, which again is great because we really want to move on. So this was the part where we look at deployed censorship, and now we will talk a little bit about VPNs, as like one important tool for censorship circumvention. So please go ahead, Ritika.
Yeah. So are you able to see my slides? Okay.
Yes.
Perfect. Yeah. So I haven't timed this perfectly, but I'll like give you a flavor of what this work is about. So this is basically a big portion of my dissertation work. Yeah, basically in the past few years, you might have noticed the fame and demand for commercial VPNs has been steadily increasing. It was once developed as an enterprise security tool, but it has now found its way into a regular internet user's toolbox. So we definitely wondered why this was the case. And as you know, there are numerous reports and news articles every day about how internet traffic is increasingly being disrupted, tampered with, and monitored by ISPs. So this is not just like in the case of like censorship, as we're talking about in this workshop, but also in against net neutrality, and there are other cases where these things are coming up. And yeah, reports of ISP selling users data and the increasing geo restrictions in terms of censorship, in terms of geo blocking, has all fueled an increased public awareness of online risks among all kinds of users. On the other hand, we're also seeing users turn towards privacy enhancing tools such as VPNs as somewhat like a panacea to overcome various security privacy issues. Even things like censorship and information restrictions are included in this. This is all fueling the growth of the commercial VPN ecosystem into a multi-billion-dollar industry. But given the shift and their increasing popularity, understanding how users interact with and use VPNs, as well as doing technical investigations into whether these VPNs are actually providing what they promise to do, is extremely important. And so in this talk, I'll go over two of my research projects. The first one where we studied the VPN users and VPN providers, and the next is the VPN Analyzer tool that we've built to investigate VPNs. So first, like I said, we set out to answer fundamental questions about the VPN ecosystem and its users. For instance, in using a VPN, a user essentially transfers trust from their ISP towards their VPN, but we don't yet know what their perceived benefits are to using these VPNs. So what features encourage them to make this shift? On the other hand, some parts of the industry have been known to use various marketing tactics and dark patterns. I'm sure many of us have seen the sort of discounts that I've put up here on the slide, things like heavy discounts that seem to be on a time limit, which just reset, after a while. And we don't really know what impact these tactics have on users, and we don't have the visibility into the industry to understand the reasons and incentives to sustain these kind of practices. So in order to gain a clear understanding of like such a large consumer ecosystem, we really need to be studying both the users and the VPN providers in tandem. So it's important to see issues from both perspectives and report any gaps in understanding and create knowledge that can fill some of these gaps. So to that end, we were the first to conduct a multi-perspective study of VPN users and providers and augment them to extract insights and actionable recommendations to improve the ecosystem. So we developed a user survey using a 3-stage development process, and we created a VPN provider interview questionnaire as a counterpart to the survey. But I won't get into the process and the analysis methods of like how we did the study, but I'll just like skip to the results so you can, you can learn about all of the methods from our papers. So the first question that we set out to answer was, why do users use a VPN? So I want to note that this study was mainly focusing on US-based VPN users. So here we were seeing that users typically use VPNs for security and privacy, and only a few of them, understandably list circumvention or torrenting as a reason. But so when we were trying to learn about users' needs and requirements in a VPN, we saw that speed, price, and easy to use GUI were among the top 3 factors or requirements. And price is a big criteria for limited to moderate expertise users. So this expertise level was something that we asked them questions about at the beginning to sort of categorize people into different security and privacy expertise levels. And so here we were seeing that for limited to moderate expertise users, things like discounts and marketing around these factors is bound to have a vast effect. And so given the different needs and criteria, we also wanted to understand what resources users typically use to discover and choose the right VPN for themselves. So we saw that users use search engines and VPN recommendation websites and reading the VPN provider's own website to find a VPN for their needs. They lean on these methods more than traditional methods like word of mouth from friends and family. And I also want to specifically highlight that the recommendation websites and search engines here, that more than 94% of the users that use these recommendation websites rated them as trustworthy. And we'll come back to why this is actually important in just a bit. And the next thing we wanted to have users explain was their threat model and who they're protecting and securing themselves against. So we find that hackers, ad companies, and their ISPs are the top 3 entities in the user's threat model. And we find that fear of foreign or domestic government tracking is much lower. So this was really interesting to us because post-Snowden's surveillance revelations in 2014, there were a lot of reports suggesting that users are moving towards privacy tools such as VPNs or anonymity tools like Tor. But our results indicate here that there is a possible shift in users' attitudes, maybe 8 years from when that happened, to show a growing concern towards corporate and advertisement-based surveillance. Next, when it comes to users' mental models, we find that almost 40% of users have a flawed mental model and think that the ISP can still view certain attributes about the websites that they visit when they're on the VPN. Now, this worryingly included users of all different expertise levels. And on top of this, another 40% of users were also unsure what data VPNs can collect about them. And some even thought that VPNs can collect really sensitive data like private messages or keystrokes when you're connected to it. So all of these results suggested that we have a long way to go when it comes to user education. And quickly from our VPN provider interviews, we were able to extract some key themes from the responses. And in this slide, I've just listed the key themes that came up. But I'll talk about the key areas of misalignment that we found, when we surveyed the VPN users and we talked to the VPN providers. One of the biggest misalignments that we found was users' reliance on recommendation websites. So this is what I mentioned before. So if you just Google best VPN for whatever purpose you wanted to use it for, if you just Google that, there are a bunch of websites that come up on the search results, and a majority of users indicated that they rely on these recommendation websites, and close to 94% of those users mentioned that they think that these websites are trustworthy. But 6 out of the 9 VPN providers that we interviewed emphasized that many of these websites simply just run on money, and they even auction off the #1 spots on the rankings. Sorry. The providers specifically say that the recommendation websites and the VPN review ecosystem is largely money motivated, and they're not really objective about the rankings. And since these recommendation sites stand to make a lot of money from affiliate marketing and rankings, they'll continue to exploit users unless security and privacy advocates like us can shed light on these behaviors. Yeah, so the next key area of misalignment is the user's view on data collection. You'll recall that over 40% of users were not really sure what data can be collected about them by the VPNs. And a number of them even suggested that they think sensitive things like private messages are being recorded by the VPN. But on the other hand, the VPNs say that they clearly communicate their logging practices, their data protection methods, and they have audits to back this up. But our recommendation was that they really need to focus on better communication strategies and effective user education campaigns. So we saw how we can use insights from studying VPN users to improve the ecosystem. But there's also a key factor that we needed to evaluate, which was whether these tools are actually doing what they promised to do. And this is important because, as users mentioned in our survey, they use it for security and privacy purposes. And there's also been other reports and stories out there that are highlighting the deceptive behavior of VPN providers. But the technical side of this investigation has received relatively little attention. So I just want to quickly say that we built a tool to address a lot of these challenges, and the work and deployment of these tools was this tool was up took around 2 years for us to make it. I think I'll just leave the slide up, but yeah, we wanted to create a extensible test suite, and we also wanted to facilitate crowdsourced data collection. And at a high level, this is how our tool works. I'll leave you to go back to the slides and look at it yourself, because I want to go through the results. So one of the biggest issues that we found was traffic leakages. So this is really important in the context that we're talking about in this workshop, because if you're using a VPN in a country where it's banned to look up websites that are blocked by the government, any leaks in the VPN would leave you exposed to being discovered by the government or being targeted by whatever agencies are in charge of these things. So we found that not only is VPN support for IPv6 pretty low, 5 VPNs even leak all of the IPv6 traffic to the ISP by default. And next, when we investigated how VPNs handle stress tests such as tunnel failure to see whether they fail open or do they fail closed, we found that 26 VPN providers, that is 1 in 3 of the VPN providers that we tested, would just leak users' traffic to the ISP upon tunnel failure. And this is especially worrying because, like I mentioned, a tunnel failure can be induced by any motivated network operator or ISP. So in this case, a sensor would just have to drop packets to what they suspect is a VPN provider's server. You just drop packets for a couple of minutes. And in that case, 1 in 3 of the VPNs that we tested would just leak the traffic to the user's ISP. And we also found that 2 VPNs were configured in such a way that they only tunnel browser traffic by default. And it's not very obvious from the tool itself that it only tunnels browser traffic. So if you're using a command line tool or a different app that's not a browser, you would still risk your data being exposed to the ISP. And we also took several efforts towards our ultimate goal of making VPN investigation easier and help users make more informed choices. So we worked with Consumer Reports Digital Lab, and they released a report which has been cited by elected officials, calling on the FTC in the US to regulate the VPN ecosystem. And our studies show that though users have a heavy reliance on VPNs and have security and privacy expectations from their provider, not all of the VPN providers live up to their promises. And identifying and investigating these inadequacies is not trivial for a regular internet user. And we want to help them improve their security behaviors and expectations through our research. So this tool and the materials related to our work has been published on our website, and you can look up information about other related projects on this website as well. So yeah, that's my presentation, and I'll quickly open up for questions.
Yeah, thanks a lot. Also, a lot of interesting data, and I encourage everybody to read the paper as well. I have a question about the user study. So was that focused on the US? Because I think in a recent discussion, and I think it was more related to identity management or whatever, I think somebody claimed to me saying that there is actually a difference where people in the US rather trust or don't trust their ISPs and have potentially more trust in the government, while in Europe it's kind of the other way around, where people trust rather their ISPs but not the government.
Right. Yeah. So this user study. So initially, when we ran the user survey, it was global. It was we just publicized it. But since we were working with Consumer Reports, which is a very US based organization, the skew of who responded to the survey was very heavily US based. So we for this paper we decided to only look at the US based sample, because then comparing and making comparisons would not be sort of prudent, because we had 1,200 users from the US that responded, only 400 from the rest of the world. So we wanted to do this study first, and then maybe follow up with another sort of study with focusing on different countries. And so I think my colleagues back in my lab at University of Michigan are working on studying censored countries and censored countries users specifically in the context of VPNs, because that's a completely different story. And we've been talking about in this workshop, there's completely different threat models there. So
yeah, and that's also something that I think came up earlier, that more data on how VPNs are used in these heavily censored countries, as well as what the user expectations are over there, would be very interesting. Yes.
Yeah. And I've actually had a lot of conversations with VPN providers, and in the context of this, like censorship and how they sort of react to this in general. So, like I mentioned, I put up the link for like our Russia-Ukraine work, where we also worked with VPN providers in that. And yeah, they also mentioned that the main issue with the VPN providers is that it would work if a user uses a VPN to get around censorship. It would work, but getting the tool to the user itself becomes an issue because certain countries have already caught onto the fact that VPNs can help in circumvention. So they started blocking the VPN websites. They started blocking the downloads of the VPN tools. So yeah, getting the tool to the user is a big problem. And like there are other things like Outline where anybody can set up a server, and once you have the Outline software, you can just get the server configuration and plug it in, and it's like a it's more of a self-hosted sort of VPN server that you can share with other people in your network to get it connected. So those kind of things are also getting, they're proliferating a lot in the context of censorship.
Yeah, and I think this was also mentioned earlier that there are countries where VPNs are actually illegal. So would also be interested about user behavior in those countries. So we have a question in the queue. Go ahead.
Thank you. Such important work. Thank you for the presentation. And I just wanted to understand what the term like traffic leak meant here. So after a tunnel failure, is the implication that it's like not going to the VPN at all? It's like just using the ISP in that case.
Right. Yes. So in both the IPv6 case and the tunnel failure case, what we mean by traffic leak is that the expectation is that the traffic goes through the VPN tunnel to the VPN server. But then if a network adversary were just to drop all traffic going to a suspected VPN server and waiting like 1 minute or 2 minutes, what would happen is any traffic that's exiting the user's machine would just be going through the user's ISP. So any DNS queries, anything that you make that's out of, basically the tunnel has failed, and anything that's outside the tunnel is now just like normal traffic to the ISP. So if you're using HTTPS, there's, those things are fine, but then anything that you think is going to be protected, like DNS queries or the SNI, any of those things are still being exposed to the ISP. Yeah.
Thanks. That's really appalling and sad, I suppose. But
yeah.
fine.
Yeah. And this is even in the case that you turn on a kill switch. We found that a bunch of, I don't remember the number now, but there are a lot of VPNs where even if you turn on the kill switch, there's like some mess up in the implementation where even turning on the kill switch doesn't protect you from this sort of tunnel failure.
So Corey, I'm not sure, do you still want to ask a question quickly or not?
Sure, I'll be very quick. Since you mentioned a couple of tools scoped specifically to browser traffic, I was wondering if in your comparison you looked at folks' mental models for Tor as a VPN-like tool with different security and privacy properties.
So we didn't explore Tor as part of this study because there have been other studies in the past that have already focused on Tor and uses mental model of what onion services look like, or what they expect from Tor and things like that. So we didn't sort of make that comparison here, but I think that would be a whole different sort of idea, especially in the US. If you're thinking about it, they might have a lesser understanding than the people in different countries. But yeah, we only looked at VPNs and commercial VPNs specifically.
Understood. Thanks.
Okay, thank you a lot for everybody who presented. Very good presentations. I learned a lot. So we have about 10 minutes for an open discussion. Again, I encourage everybody to turn on your video so we can see some faces. And I would like to give Michael also the opportunity, because he joined the queue earlier and said he wanted to go back to the open discussion. So if you want to join now or say something now, that's your chance.
Hey, cool. Thanks. I was curious about the use of VPNs in relation to the earlier talks about India, Pakistan, and so forth. Listening to these things, I just thought that most people there would resort to using a VPN pretty much for avoiding blocking. So my question is how common that is. I mean, is it that tons of people there are using it, or not so many, or there's also the question of legality. So I was just to get an overview or a bit of feedback on that would be interesting.
I can maybe respond to the legality part for India, at least. So VPNs are not officially banned in India, but so there's two parts. One is in areas like Kashmir, actually people, especially during sort of times of high tension, there were reports that the police was like looking at basically if you had a VPN app on the phone and then harassing them or assaulting them. And in response to the fact that many people are using VPNs for circumvention, the government had actually issued regulations for VPNs that required them to store metadata and traffic data for like when you're using VPNs for personal use, and the commercial, sort of work-based VPNs were actually specifically excluded from that regulation. In response to that, the VPNs that haven't complied, some of them just stopped servicing Indian users. And after that, there's research by Ayn Ghazal, I think. I'm not sure whether it's published or not, but I think the initial results showed that there was some blocking of VPNs on Indian ISPs. But this may be after the regulation, then like VPNs that didn't comply maybe faced some blocking.
Yeah, but it definitely feels that this is an area where we kind of would like to have more data. So one thing on the to-do list.
For users specifically, I don't think we know like how prevalent the use is for circumvention and other purposes.
Thanks.
Okay, I also want to give the word to Mallory because this was the same. She joined the queue much earlier for some question or comments.
Yeah, thanks, Miria. So my question is maybe for everyone who's been thinking about this issue, welcoming thoughts here. But so rewinding about 5 years when I was first perplexed by this, actually had a fellow working with me at the time from Eastern Europe who, was saying the more we implement at the protocol layer circumvention or resilience or censorship hardening methods, we're talking like encrypted DNS and so on, the more it will provoke censors to take the next step. So you're sort of talking about this cat and mouse game that we're familiar with, right? And he was saying, that like the next thing that's going to come is going to be worse. And I feel like that was a useful point. I think what he was asking for at the time, if I remember, was just like a plan, right? Like, okay, so we get encrypted DNS and then we go for ES&I. And, he was just saying like, we need to be a few chess moves ahead. And now I think that's more or less resolved because I think that what we've seen is that, censors are going to be, so like sufficiently motivated censors are going to use things like DPI. They're going to use the heaviest artillery they can. And then also I think we've seen from a lot of these presentations is they use multiple methods at the same time. It's not just a matter of like picking up the new tool that's available. But now I'm a little bit worried about us dropping some of the easier, or not dropping, but like deprioritizing or undervaluing some of the censorship circumvention methods that are more lightweight. So realizing that DNS is probably pretty easy to now use encrypted DNS, but also to for the censors to sort of get around it and censor more deeply, that we then undervalue that sort of method of circumvention. And so I just wondered if folks had thoughts on like how we keep paying attention to, or how we keep valuing, how we keep reusing the constituent pieces of circumvention technologies, even when they are sort of lightweight and simple. So I don't know, maybe that's not on everybody else's mind, but it certainly is mine, right? I need to keep convincing people that yes, like encrypted DNS is super easy for a sufficiently motivated censor to go around, but it's still important. We still have to keep implementing it.
So maybe a high level answer or additional thought to that is like my sense is actually that this is not necessarily censorship circumvention, but it's based on the design of the internet. It's not, the internet is not designed on like this single protocol stack that you have to use forever. And so whenever you start censoring in one protocol, in one stack, in one layer, or filtering or blocking or however you want to call it, there's always a way around, because you can always develop something that is not reliant on like this specific protocol, because that's how the internet is designed. And so it will keep being a cats and mouse game, but I don't see any side kind of winning, and I see that like whatever we do, however we keep evolving the internet, is actually helping this basic idea of the internet, that people can access information.
Right. No, that's a fair response. I think that makes sense. I guess I just want to think, you know, for small lightweight protocols that are developed in this cat and mouse game, and maybe only for that specific purpose. And I mean, encrypted DNS has more than just circumvention properties. It also has privacy properties. But like, how do we keep valuing those contributions in the long term and not kind of move on to the next thing because that's no longer fit for purpose? I don't know the answer. I don't know if even my formulation is clear, but happy to put a pin in this for maybe a future discussion. Although it does, I think, really implicate, like this is where we really implicate what the technical community and what protocol design can actually do, which has been hard to determine the last couple of days, but here it's a lot easier.
Yeah, so the floor is open for more comments, questions, thoughts, or answers. But I also just see that we only have 2 minutes left, so maybe it's actually time to wrap up here. We don't have much time to wrap up. I was hoping actually we could also kind of recollect a little bit what we discussed the last 2 days. As I already said, I learned a lot, not only today, but also the last 2 days. And I hope that this workshop and the report we will be writing will be a start of a conversation. So I hope we will have a very comprehensive report at the end with a lot of pointers to additional data and work that's going on that we can then publicize and discuss in the IETF or in other communities. So that was kind of my goal of the workshop. And I think I'm very hopeful that we're getting there. I would like to request everybody to interact a little bit more with us and kind of use the mailing list to send an email with your main takeaways from this workshop. I would be really interested to hear that, and we don't have time for that now. And I believe that could also trigger some discussion. So please, you know, recollect about what you've heard and learned the last 3 days, and send a short message with some thoughts to the mailing list, and we can have more discussion there. And again, also please contribute to the report. That would be very helpful to us. Any final thoughts? Okay, then again, a huge thanks to everybody who presented today and the last 3 days. And I want to look at my co-chairs of the workshop and give them the opportunity to say something. I see at least Mallory is still here, Drew is here. I'm not sure if we have everybody here actually.
Just want to thank everyone. This was really, really interesting. This was my first IAB workshop that I was organizing. It was a very good experience. Thanks everyone for helping out throughout our experience. The final thing is report. We're looking forward for more conversation. We would in fact welcome sharing of more information on our email list as well. That's why we created this email list. All of you are there. So if you have more research, more topics that went unanswered, and if people have thoughts, let's take it to mailing list. That's where we have the best discussions in IETF anyways.
Mallory, you have the last word.
Oh, thanks. Well, I just want to appreciate all the speakers, especially the quality of the talks was so high. I just really learned a lot. Even though I'm really familiar with a lot of these topics, this sort of evidence-based discussion can be so much deeper than what we're typically used to. And so yes, while I agree with Drew, a lot of good conversations happen on IETF lists. When you combine that then with real scholars, real scholarship, and diversity of perspectives, I think that's actually the greatest mix. So looking forward to talking to you all on the list. And thanks also to the co-conveners from the IAB. This has been a lovely working project. Thanks.
Thank you. Bye.
Thank you. Thanks a lot.